how Java treats strings, or objects for that matter. Not all objects, but most objects. String is an object. It's not a primitive data type, it's an object, okay? And we know this, A, because we know which ones are the primitive types, but also because objects in Java by convention start with an uppercase. So the first letter in string, the S, is capitalized. And here's how strings work at a detail level. Strings, so we saw that primitives store their values in whatever space they have for their bytes. Objects, on the other hand, store a location that stores the value. It's like they have to do one jump before they get to the actual value. So let's look at this in practice. So for example here, this line, string A equals hello. The variable A, which will be of type string, and what we will do is we'll say, okay, the memory address that contains the memory address where that string lives is, say, address number 1. Okay? Yeah, address number 1. So, this is what's going to happen. In address number 1, which is here, the memory address takes 4 bytes, which are those 4 bytes, and that is going to point to, let me see, what is 12A in binary? Is that number. Okay. So this one's going to be 0, 0, and here we have about 10, 0, 1, 0, 1, 0, 1, 0. Okay. This number, okay, this number is actually the number 12A, okay, 12A, which is here. That tells the computer that my string starts here, okay, and the letter H will be 2 bits for the letter H, so that will be, I don't know, 0 and 1 0 1 1 0. That's for the letter H. The letter E for hello, the letter E will be 1 1 0 1 1. That the letter L will be 1 0 1 0 1 0. Again, another L, and the letter O should go in here, 131, and then it should go in here, whatever that letter L is. Okay. So let's say it is 132. That's 132. Okay. So this is basically how strings are stored, and here's again to really understand this. String A equals hello. A will have the memory address of a pointer, basically something that points to the actual word hello. The actual word hello is for now it's just the characters H, E, L, L, O in a sequence. Okay? So string A, when Java reads this, says string A. Okay, A will be stored at memory address 1. Okay? So it'll go to memory address 1. It'll read this 4 bytes, and these 4 bytes will tell the computer where in memory is the actual contents of the word hello contained. And these 4 strings in binary spell out 12A, which is here. So then from here on, I'm going to use 2 bytes for each letter of that string. And this is going to spell hello. Okay, these are the binary contents of the word hello there. Okay? Again, the variable goes to just a pointer that will tell the computer where the actual contents are. Why do we go through these double jump? Why not just store the address of the contents right here? Well, that has to do with which parts of memory the computer is using, and to be more efficient, when you create a string, you don't know. It might be very long, it might be short. So what Java does is it says, okay, you know what? The variable, I know it's always going to use 4 bytes. Okay, 4 bytes. And then those 4 bytes are going to go to some memory location where I have enough space for hello. Okay, and that way it can organize some spaces of memory in a much better way. Okay, but just know that objects actually point to an address that points to the actual contents of the string. So let's go to the next one. B is goodbye. Let's assume the the address for goodbye is stored in location 121. So let's look at, let's fill it with some color here. 121, here's 4 bytes that will tell us where the actual string goodbye will be located. So let's assume this is, I don't know. So this will spell out some memory address. Let's assume that that memory address might be, some other memory address that's actually going to have the contents of the word goodbye. Now when I say this, string C equals A, what I'm saying is that C, okay, C contains this. C is equal to 1, okay? C is equal to 1. So in this case, C also points to here, which in turn points to this over here, okay? Now, so C is equal to A. The string C is equal to A because they are actually the same string, the same contents, right? Because A, if you look up A, you go to this memory address, you'll find this pointer to these contents. When you look up, when you do C equals A, what you're saying is, hey, let's create a variable C that actually also is stored in memory 1, and this again is a pointer to these contents. So whatever happens to A happens to C as well, because they're both pointing at the same memory location. We're going to see a simplified version of this in the next video.